Well, hello. Hey, welcome back. Hey, you should be watching this video. We'll be talking about this in class a little bit too. I know it's the new year, and so we're going to be talking about lesson 6.4. So now there's about 5 or 6 of you that are new to my class, and so I'm going to post these 3 videos so you can see where we've been at. This lesson right here is an assignment that we're going to collect when we get back. If you haven't done it, it won't count against you if you weren't one of my students. But that's only about 6 of you. So the rest of you, and if you were in another class, you had to do it. So if you were here at American Fort Junior High, you had to do this video. Or you had to do this lesson. So every teacher has already taught this, and I'm just going to expect to be able to get it back from you. We'll work on it. Okay. Now, if you're new to my class, what you need to understand is that's your responsibility. Your homework every night is to take notes on these videos. I'm going to try and keep these videos to about 15 minutes at most. And you're going to take notes. It probably takes you 20 minutes to actually take notes. You should have a note packet with you. If you can't see the note packet, it should be available and posted on the website on Canvas. If you're new to Canvas, well, you just need to get used to it. Ask us questions. Ask a student next to you how to do it. You should be just fine. All right, so now we're going to be going to page 14 for notes, and then you should have your work assignment, and that means if I'm correct, you should be on about page 37 to 40 to do your work. Okay, now remember, there's a specific way we're going to expect you to do this in all of the 7th grade at American Fort Junior. What you're going to be expected to do is solve and check, not just check. You're going to have to show the steps to solving. Okay, so let's look at this. Okay, now when we got done with lesson 3, I told you guys that I really expected that pretty soon you're going to get to where you don't have to draw the figures. But again, if you were to draw the figures, draw those over to the left. What would this look like? So you should have that. Now, by the time we got done with lesson 3, you should have started to see there's a pattern. What we're going to say now is, what we're trying to do is undo what's happening to x. And we're going to undo according to the reverse of order of operations. So it may be a really good idea to go ahead and write down here that triangle for the order of operations that we taught you. So, and if you're new to us, but you should by now know the order of operations. This is parentheses, exponents, multiplication, division, and addition and subtraction. Remember, the reason why we do it this way is because multiplication and division, when they're next to each other, we go left to right. And the same thing with addition and subtraction. If subtraction comes before addition and they're going left to right, you do the subtraction first. Okay, but we're going to be talking about undoing. So how do we undo multiplication? So some of you were guessing and checking, you looked at this, and you knew that you came out with it x equals 17. Well, remember what we're trying to do is show our work for the simple problems. So when we get to the harder ones, you've already become accustomed to how to show your work. So how do we undo multiplication? You undo multiplication with division. So we're going to divide both sides by, well, we want to get 1w. Okay, we want to get the 1w by itself. So we want to know, we're going to divide both sides by 3, which means 51 divided by 3 is 17. So w equals 17. Okay, so now when we do the check, we rewrite the equation over here where it says check, right? Over here, we're going to rewrite the equation over here. You notice we've rewritten it. Now what we're going to do is we're going to plug in. Remember what we've just done, what we did in chapter 5 was say if these two expressions are equivalent, we can know that by checking, by plugging any number in to see if we had it right. That's the whole purpose of you going through the check. So what we're going to do now is we're going to draw a line down here to the middle. We're going to plug in what we said it is, because that equal sign means there's one value that makes this true, that 3w would equal 51. We solved it to say that it's 17. So we just checked. We already knew this was 51. So now we're going to say 3 times the 17, and 3 times 17 is 51. These two are balanced. So our solution is that w equals 17. Notice the steps. We went through the steps of solving. We checked it, and then we said, yep, that's our solution. So let's look at this one. This one's harder. Okay, this one's harder. But remember, if you drew it out and you said, oh, I have 4 p's is equal to negative 36, then you know that 4 times some number equals negative 36. So a positive times what equals a negative? And it's going to be a negative, right? So we can already understand that we're going to have a negative answer, right? So what we're going to have is divide. We're going to undo multiplication. The way you undo multiplication is to divide, because 4 divided by 4 is 1, right? So that simplifies, right? So that means we have to do the same thing to this side. So we're going to divide that by 4, and negative 36 divided by 4 is negative 9. So P equals negative 9. That's solving. Okay. Now what we're going to do over here, we're going to plug this in because we're pretty sure this is true. Then we're going to copy it over. Now we're going to plug it in. We're going to say, well, we have 4 times, we're going to say that's negative 9, right? Is supposed to be balanced with negative 36. Right? And 4, a net positive times a negative is a negative, and 4 times 9 is 36. So if this side is equivalent to the other side, if the left is equivalent to the right, when we plug in negative 9, then negative 9 is a solution. Notice if you put in negative 6, this would become negative 24. If you put in positive 9, this becomes positive 36, which is not the same as negative 36. So we would have proven that we had the wrong solution. You're trying to find P. Okay? Right. So then we look at this next one. Now remember, we're trying to undo something, right? So we're going to talk in class a little bit more to help you understand this a bit. We have to follow the order of operations again. But remember, when we were doing it before, when we do order of operations, what we're going to do is we're going to go parentheses first, then exponents, then multiplication and division, and then addition and subtraction. But we are undoing it. So that means we're going to undo addition and subtraction first. Then we're going to undo multiplication and division. Then we're going to undo exponents. Then we're going to undo the parentheses. We go backwards. We're undoing it. So if we look, the first thing we're going to undo is addition and subtraction. So the addition that's happening is we're adding 14. The question we have to say is, how do we undo adding 14? Well, we do that by subtracting 14 from both sides. Okay, so remember what we're doing right now. We're saying that we're going to have negative 36 minus 14, right? So be careful on this. This is where you have to be careful. And this is why the value of the checks, right? What I taught you, make everything into addition first. Negative 36 plus negative 14, right? So that means we're adding 2 negatives. If you need to still draw it on a number line, that's okay. So you're going to be at negative 36. When you add negative 14, you go that way. Zeros over here, so we're at negative 50. So that means 5t equals negative 50. Okay, and we're going to re-summarize what we have, and we look at it now, and now what we have to undo is the multiplication. So we're going to undo multiplication by division. Okay, so we're going to divide both sides by 5, which means 5 divided by 5 is 1. We have 1t. That's our goal, to get 1t. Okay, and then when we look at this, negative 50 divided by 5 is negative 10. So we think the solution is that t equals negative 10. But now what we need to do is check it, right? You want to be correct. The beauty of this is when you get done, first of all, you need to understand 50% of it is solving, 50% of it is checking. If you don't do the checks, you can't. You're just not going to get you can't get a 4. If you don't do the checks on the homeworks, you can't get a 3. You've got to be able to do the checks. We've been working on the checks for a whole unit. Okay, we said that we think it's going to be negative 10. which means we need to copy the original equation. Always copy the original equation. Now, some of you are going to struggle with this part. Notice where we wrote the original equation, right next to where it says check. Okay? You're learning a pattern here. Now, if you choose to do a different thing, let's say you get wild and crazy and you say, Mr. Bruno, I'm not afraid of fractions. I'm going to go ahead and divide everything by 5 first. That's awesome. It's going to be harder, but it's awesome because in your understanding, you don't have to do it that way. But the safest way is to undo it. Just like we're going to talk about wrapping a present, and many of you just opened up presents in the last couple of months. Some of you are going to unwrap presents during Kwanzaa, and that's wonderful. And so, but what we're going to talk about how you unwrap and how you it was wrapped and how you unwrap it. We're going to talk about that in class, okay? So what we wanted to make sure you understand today is that we're drawing this line down, right? And we're plugging in -10. So we're going to say we have 5t, 5 times, and we said t was -10 plus the 14. This should be really familiar. And over on this side, we had -36, right? So we get 5 times -10, positive times a negative is a negative, so -50 plus 14. If you need to, you do that on the number line. If you're at -50 and you add 14, you're going to go that way. Zero's like way over here, right? So you don't have enough, as one student put it, you don't have enough to cover the -50, but you're going this way, so you're going to wind up at -36. And this side is -36. So if these two come out balanced, then you have the right solution. If they don't come out balanced, there's a mistake somewhere, and you go back to check for your mistake, all right? So when you look at this, first thing you always do is go back and check your math here. Trust yourself, trust that you probably did it right. Check the way you checked. If you didn't make a mistake during the check, then you go back and look and follow your steps on solving an equation. Okay? That's what you're going to do. And that's what's going to make it so powerful is you can check, you're going to learn from your mistakes. A students, B students even, say they learn from the checks. If you want to learn how to do this correct and you want to make it so you make less mistakes, you need to do the checks. So you learn from your mistakes. You're going to make mistakes. This is brand new. Okay? All right, so now we're going to do this one, right? Okay? Okay, so when we're looking at this, we're going to tear this apart. Remember we talked about with IVESA. Okay, write down the words for IVESA. Remember, that stands for I-V-V-E-S-A. Can you remember what this stands for? Fill it in. Go check your notes somewhere. See if you can remember this. Let's quiz you real quick and see if you can figure that out. Okay, so when you look at this, the first thing we're going to do is identify the question. Okay, which means we're going to go over here and we're going to look and see what does it say, what does it want us to do. Okay, and what they want us to do is write an equation that relates the number of marbles in 2 jars. All right, so we're going to use numbers 78 and 6, and we're going to use the variable g, right? G happens to be, they want G to represent the number of marbles in the green jar. Okay, so that's what G represents, right? Now let's look at the other factors. We also have there are 70 marbles in a yellow jar. And we also have that the yellow has 6 times as many marbles as in the green. Okay, so those are significant. So I'm going to tell you that when you look at it, you want to kind of give yourself a thought. If there's 6 times as many marbles in the yellow as in the green, let's just say, what if you had green? Just to think about it. What if you had green versus yellow? If there's yellow has 6 times as many. If there was 1 marble in the green, how many would there be in the yellow? There'd be 6. If there were 2 marbles in the green, how many would there be in the yellow? Well, there's 6 times as many, so it'd be 12. If there was 5 marbles in the green, how many would there be in the yellow? It'd be 30. So let's say there were N, right? Or they're going to say G. There's G marbles in the green. How many marbles are in the yellow? There'd be 6G, right? So G represents the number of marbles in the green jar. Write an equation that relates the number of marbles in 2 jars. In the 2 jars. That means the yellow and the green jar, right? And there's 78 marbles that are green. Or 70 marbles in the yellow jar, right? Well, every time we were figuring out how many in the yellow were, that was 6G, right? So there's 6G equals 78, right? Because there's 6 times as many marbles in the yellow as in the, so if there's 78 marbles, now what we're going to do is just divide, to figure out how many are in the green. We just solved now. We're going to divide both sides by 6. We get that we have G equals 78 divided by 6 is 13. There's 13 marbles in the green jar, which we found G. Now we got to say, if we're going to have the green plus the yellow, there are 78 in the yellow, and there are 13 in the green. We have 91 marbles total. Okay, that's what we did. We gave ourselves a visual model. Here's what's happening, right? Then we defined our variables. They gave us that G was the number in the green jar, right? We wrote our equation. We solved it. And then we figured this out, and we said we gave an answer. There are 91 marbles total. Okay, this was a little long, but it was about story problems, so they won't always be this long. Okay, you're going to see some more in your notes. We're going to talk about how to do those 2 problems in class. So we'll be discussing this. If you think you know how to do it, hey, go ahead and do it and be ready for the conversation in class. See if you can do it right. All right, hey, this was the day. Good luck.